Hi, here's Maciej again. Today we are going to talk about generating tiles for ZX Spectrum Next for assembly language. And we are going to talk explicitly about the tiles where each tile takes 2 bytes of information. In the previous video, I was talking about the tiles where each tile has only 1 byte of information. And now we are going for 2 bytes. I will link the previous video down below, and it has some information that I'm not going to repeat right now here. So I would recommend, to start with the first video. Before we start generating tiles, I will go to the sprite editor, because now we are allowed to use all 256 colors, but with some kind of limitation. I don't know where is the limitation. It's a good idea, good pattern. Anyway, so each pixel takes 4 bits as it was before. So each sprite can have only 16 colors. There is no change in that. But now each sprite can have a different palette offset, which means you have the same set of the pixels, but they can have a different colors. This is similar concept what, for example, Doom has, where you can, and with this trick you can achieve things like a shadows, for example. So as you can see, when I'm changing the palette offset, the color of my sprites are changing as well. But there is still 4-bit color information per pixel. And now let's have a look on the editor. Down below, when I move my cursor over a pixel, it shows I9, and this is I12. This is the color offset that goes into the exported sprite file. Now, if I change the palette offset to, let's say, 3, the color that was previously 9 is now 57. So you might think, okay, but how are they going to store 57 in a sprite file? We are not going to store it there. This is just for the display proposal. I mean, this is how the program works, okay? So when you export this sprite file, it will contain only the colors from 0 to 15, independent of what is shown here. This is just when you switch the color palette, the program just recalculates the pixel color to show it properly, and it displays it here. That doesn't mean that it goes into the exported file. So basically what that means, if you are in the palette offset 7 and you move here to, I don't know, let's say this is 10, and you start painting 10 here, and it shows 105, then you can be dead sure that 10 will go into the file. And if you go to the 0, it's 9. Okay, but doesn't matter. It will go into the sprite file. So basically, the sprite file is exactly the same, or the file containing the tile definitions is exactly the same, whether you use a tile map which has 2 bytes of information or 1 byte of information. And when you choose these different palettes offsets here, this information is only for the display proposals. It doesn't go anywhere. It is just for you to see how it would look like in a different colored palette. But this information is not getting export to the sprite file. Where it matters is a tile map, but not this information. We'll talk about tile map right now. So I will create a shortly a pull request. If you don't see this thing into Remis sprite tool, that means that this is still an older version. But when you tick this, you switch the tile mode from 1 byte per tile to 2 bytes per tile. Now, first we are going to clean map, and it's going to ask us for the tile ID that it will use to fill up the whole screen, which is 0. And it will also ask for the palette ID, because now each tile goes with a palette. And now when we start painting, we can take, for example, A here. And we can paint also A using different color palette right here. But the funny thing is that I've changed the color palette, but it didn't change actually the display. Well, this is kind of a limitation of this tool. But down below here, you can see that this ace has a palette 0 and this ace has a palette 5. So it will store into exported tile map the proper color information, it will just not show it here. So if you're asking yourself, okay, how would look my A look in a palette 5? Then you go to the sprite editor, you select your A, you select the 5, go to the tile map, and now you see how it looks. I mean, it changes everything, that is true. So you have to just focus on the A, how it looks in this different color palette. This is kind of limitation, but I think that we can live with that pretty good. Really don't ask me why this is now blue, clear. There are some, small bugs, but we can live with that. It does what it's supposed to be doing, because still this A is palette 0 and this A is palette 5, so which is good to me. And now let's write some Bs and some other Bs in palette 0. And okay, that's enough. Okay, so what we have here, this A is palette 0 and the one on the right is 5. This is 0 and this is, I don't know, it could be 5, doesn't matter. Download map. We are going to download the map using the magical name AAA, and goes there. And now we are going to deploy it on my Next. Before that, we are using as reference this guide, and it has on GitHub examples, and there is an example called tile map, which I already have in my Visual Studio Code. Okay, first we have to throw the AA map here. We are not changing the sprites because the sprites are exactly the same as they were from the previous example, and this is the file that I did not modify from the previous example. But we have to do some modifications in order to work it, to make it run, because it's meant to work with a tile map where each tile has only 1 byte, and now we'll have 2 bytes. So there are definitely some things that have to be adjusted. And the first thing, as always, I'm not going into details of this program. There are tons of comments. There is a book about it, so there is no point to discuss it. The start of the tile map is 6,000, which is fine. And now the start of the tiles is 6,600. What is 600 in binary? In hexadecimal, decimal. 15 kilobytes. Now, it's a 15 kilobytes, but if we go to the documentation, which is here, and we look to 2560, a full size will occupy 2560 bytes. So this program was meant to work with a tile map which is smaller. And now if we will not just adjust this address, then what will happen, the tile map will run over the tiles and we'll get garbage on the screen. So what we have to do is to we have to see what is 2.5 kilobyte, and in hexadecimal it's in A00. So we are going to change this to A. So now we have enough space in RAM to fit our tile map, and the tiles follow just right after it. We can just give them some space, for error. And what else we have to do? And 6B, what is 6B? 6B is a good number because it has byte number 5, which tells us want to eliminate the attribute entry in the tile map, and we are not eliminating it, we are introducing it, so it goes in here. Because now these are 16-bit entries, very important to change the comment. And I know that when it copies the tile map, it copies 40 by 32, but now we have 2 bytes per tile, so we have to modify it so that it works. Now I'm moving my SD card from my Next into my MacBook. Oh, wait a second. Switch on the monitor. Looks better when it's on. Jesus, this is slow. Input, HDMI. Great, now let me see my recording so I can see what you can see. doesn't matter. Reset. X. Ooh. Can you see there is only A and B? Why is that so? Why is that so? Because the others had palette offset 5 and we did not import the palette, and the palette that was in this example has only 16 colors. Okay. Probably it will show, probably it will display properly if we would import the palette, but you know, you can manage it by yourself. This is the idea how it works. Have a nice day and so on. Ciao, ciao.